and we want to do it at the group level. So the first thing is to change this first option right here, the memory option. Because what happens is when you work at the group level, EEGLAB cannot load all your data sets into memory. If you have a lot of memory, sometimes you can and you don't have to check this box. But usually, if your data sets are large enough or if you have enough subjects, you just check this box. And that means that EEGLAB will only keep one data set at a time in memory. All the other ones will stay on disk until you actually need them. And the first thing we're going to do is a very simple exercise where the first time we did, like in the early study days, people were like, oh, this is so complex to do, create a study, etc. So we created a menu, create a simple study. Where you create, you select simple ERP study, you enter a number of conditions, your maximum number of subjects, you press OK, and you have two columns, one for each condition, where you put the files, so that's subject 1, condition 1, subject 1, condition 2. So here we have ignore and memorize condition. So these are two types of letters that were presented to subjects. This is subject 1, condition 1, subject 1, condition 2, subject 2, condition 1, subject 2, condition 2, subject 3, condition 1, subject 3, condition 2, etc. And so you can put as many as you want here. And then you press OK, and you get this plot where you get the grand average ERP across all your subjects. You can click on the individual plots, kind of zoom in, and then you have this interface, which I'm going to talk about a little bit later. But basically that's it. So that's the first exercise. So from the data you copied yesterday was on the key. It was a folder named studies, and this is where the study is. And so just basically follow through the slides and create this simple study from the data that we gave you yesterday. And if you need the data, we have the USB keys. So here we go for like 10 minutes. Let's just do this very simple exercise. The data is in the studies folder that was distributed yesterday, and you can use the EEGLAB we used yesterday as well. Create study, simple ERP study. You say I want 2 conditions and 3 subjects, and that's the interface. And then you type ignore here, memorize here, get your subjects, S01 ignore, S02 ignore, S03 ignore, memorize, and you press OK. And because I had already computed it, it asked me if I want to erase it. That's it, and then you can plot. You can click to plot individual. So that's it, that was the exercise. Now that's the easy way to do it. There's a harder way. And the harder way is to select each individual file and then enter subject, session, condition, group. You can also select independent components by residual variance. We're going to talk about that tomorrow. If you've set up this information in each subject, as soon as you select one file, so for instance, you would select here ignore, it's going to populate automatically the line with the correct information. So it means here, if you have 13 subjects, you would have to select all these files and then you press OK. You can select pretty much any types of, you can create any types of design. For instance, in this current version you're using, which is somewhat limited, you can create all these types of designs. So 1 by n unpaired design, so patient versus control, for instance, group A versus B. 1 by 2 paired design, so stimulus A, B, and C, and D within one subject. N by m paired, where you would have stimulus A and B, drug A and B for the same sets of subjects, or unpaired design. But basically you can do any two independent variables which are categorical, which means you can't do reaction time, you can do any continuous variable. You can do condition A, B, C, D, you can do drug A, B, C, D, etc. That's the limitation of the current version. And plus you can only do 2. And to do that in the current interface, in the new one, we'll talk about this afternoon, you can do as many as you want. There's no limits. And you can do both categorical and continuous variables. So here, so once you've loaded your datasets, you select your datasets, you have to create your, what we call study design. And you see there's 2 columns. There's 1 column for independent variable A, 1 column for independent variable 2, and you just select it here. So for instance, here we have 3 conditions: ignore, memorize, and probe. And so if you wanted to create exactly the same thing we did with the simple ERP study, you would select ignore and memorize here, because we just selected 2 conditions. And so if you select the 3 conditions, that's a 1 by 3 design. So that's the ERP that would be plotted here. So actually, that's the information for selecting the conditions comes both from the information you entered when you created the study, and also from the information of your, what we call time locking events. So it's going to go in your EEG data and your events, and it's going to look at all your fields of the time locking event, and then it's going to allow you to select trials based on that information here. So for instance, if you have duration of event, you can just select duration here. That's a continuous variable, so that's a bad example. But if you, any kind of information you have at the single trial level, like the color, and you're presenting a square and you have the color of the square, you can select your condition here based on that information. It's going to look up within each of the datasets and allow you to select that. Also, that means that here we had 1 dataset per condition, so we have 1 file for ignore, 1 file for memorize, and 1 file for probe. So we have 3 types of letters. The task, by the way, is described in the PDF. There's a little PDF in the folder for the study. So if you want to know more about the task, it's called a Steinberg task. It's about memorizing letter. It's in this document. And so you have 3 files, but it's just the way this is designed like this. You can also have just 1 file which has different trial type. And because the study design goes and look within every single trial, you'll still be able to select different conditions, ignore, memorize, and probe. So the file structure is not that important as long as your trial are tagged properly. You don't need 3 files. 1 file is fine with everything merged. We actually have studies that just have 1 file with all the... So it's the same. These are some other examples of study. This is so you can create, so that here you can add design. So this, for instance, this was another task where there are different types of stimulus. There's audio, light, blank, and so you can select the stimulus based on, for instance, audio versus light, and then there's 2 groups of control, 2 groups of subjects, controls, and meditators. So that's one type of study design. This is a 1 by 2 design. So this is another task. This is not the Steinberg task. It's just to illustrate what kind of study design you can have. Or here you can just have a 1x3 design, and you can select only the meditators here. So you look at your subjects, you only select the meditators, and you select audio, blank, and light. So that's still a 1x3 design, but doesn't have all the subjects. It just have one group of subjects. You can select also, you can group. For instance, you can say, okay, I want audio and light to be grouped. These are my stimuli, and I want blank versus audio and light for this group of subjects. You can also exclude one type of stimulus, for instance. So here we exclude the audio ones, and I think this is based. So here what we have is that we've selected this independent variable that's called previous event, and we want previous event audio, blank, and light, but we only want the audio stimuli. So what we're going to do is we have a 3x1 design again, but now we only have the meditators, and this is only the audio trials. But some audio trials are preceded by light, some audio trials are preceded by blank, and some audio trials are preceded by audio. So this is another type of design. To get this previous event here, it's not done automatically. You have to write a 3-line script that is going to define this new event. And we can talk about that tomorrow in the scripting session. Here again, another type of design. So audio versus light, there's 2 sessions, 1 and 2. And we group all the subjects. So this is a 2x2 design. There are also 2 types of stimulus. There is the evoked and spontaneous stimulus. Doesn't matter what it means, but this is another example of 2x2 design. So here, if I wanted to put all these variables, take all these variables into account, I can't take, for instance, both session 1 and 2 and presentation, because I'm limited to 2 independent variables. In the new study design, you can just put everything together, and then as Cyril mentioned, afterwards you can just focus on whatever you're interested in. Look at specific contrast. So once you've done that, you created your design, then you want to pre-compute the data, because the data is usually large, and you can't read it on the fly from disk. So this is the pre-compute interface. So here, these are different entries. And so the first one is the channel list. By default, it computes all. We don't advise to change anything here. Then spherical interpolation is good. So that's when I said yesterday, don't interpolate your channel, single subject level. Just use spherical interpolation at the study level. Then you can remove ICA artifacts you've labeled as artifacts. Or you can remove clusters of ICA artifacts. So we'll talk about clusters tomorrow. Basically, the ICA artifact, if you were here for the special session in the afternoon on ICA, this is where you selected your components and tagged them as being artifacts. So you were, for each subject, you were going into reject component by map, and you could tag them, okay, this one is an artifact, this one is an artifact. And when you save the data, this information is saved along your data set. When you go at the study level, it's going to go within each data set and pull out that information. Okay, let's tag this component. Okay, I'm going to remove these components before I do anything with the data. Before I compute the ERP for that subject, I'm going to remove these components. Before I compute the spectrum, I'm going to remove these components. Before I compute the USP, I'm going to remove these components. This is the type of information you can compute. There's also a function to compute custom measures. So these are ERP, power spectrum, and event-related spectral perturbation. So time frequency decomposition, and ITC is phase locking factor. And they have a link between them here because they use the same function to compute them. So it doesn't actually take longer to compute one or the other. And then you can also save the single trials and recompute even if it's present on disk. Once you're done with that, you call this third menu plot channel, what do you say? Plot channel measures, and this is what pops up. On the left, you have electrodes at the group level, and on the right, you have electrodes at the single subject level. So every time you click on these buttons here, that's group level. Every time you click on this button here, that's to see what's going on in single subjects. So here, if you have all CZ selected, you plot ERP is going to plot the grand average for CZ. So that's what happens if you click plot ERP. And these buttons sometimes are grayed out because you didn't select the measure to compute them. If you select all electrodes, they're going to be all selected, and you say plot ERP, this is what you're going to get the free conditions. You can also plot the traces for the individual subjects here. So this is the grand average ERP in black, and every single trace is a single subject. You can also plot on the trace, and it's going to give you the index of the trace. For instance, if you plot on trace here, it says 5, it means you're plotting the 5th on the list. Okay, so you have to do this little mental gymnastic to find out which subject it is if you're interested to. You can also change the parameters. For instance, you plot the variable on the same panel. So again, if we look at CZ, so now we have the free condition on the same panel, so they're easier to compare. Again, on the parameter, you can plot the topography, 200 to 300 milliseconds, and now it's going to be average the ERP for each subject, 200 to 300 milliseconds. For the ignore, the memorize, and here we also have the probe condition. And then we'll see later this morning how to plot statistics as well. You can also plot statistics mask for multiple comparison, as Syria mentioned. So all of this here was because people thought, well, that's a little bit involved. You know, I just want to click simple ERP. So the simple ERP does everything for you. It finds your file, it assigns your condition, it pre-computes, and it does the plotting. But you can do it this alternative way. The other advantage is that you can compute other measures. Oops, my PowerPoint just crashed. I'm just going to kill it. So you can compute, for instance, spectrum. You can compute even related spectral perturbation. And then you can also define more complex design, because with the simple ERP one, you just constrain 1 by n. But it's good to start with. So here we're here. So here is so we did the ERP. Let's look at the spectrum. So there's many options to spectrum. Because it takes a bit longer, there's a test button. This way you don't have to, you can see how it's going to look. And basically everything you could do with ERP, you can do with spectrum. So now instead of having the ERP here, I have frequency on one axis, power on the other axis, and you can plot grand average spectrum, etc. You can plot scalp topography at given frequencies of interest, statistics, etc. And now this is the ERSP, so event-related spectral perturbation, where here you set your parameter to compute them. So it's the same as Judy was talking in the afternoon session yesterday, how to compute ERSP. And once you go to this plotting interface, you can change the parameter. So you can plot, for example, so this is the free conditions, but you can also select a time region, time frequency region to plot the scalp topography within a specific time frequency region. So now for the next 10 minutes, we're just going to try to use this more complex interface. And the first, you're going to load the Stain study. Alternatively, if you're motivated, you can also look at the browse for dataset and enter each one of them. It's 39, so it might take a while, but you can also do that. If you do that, I advise that you change the MATLAB path to be in the study path. This way, whenever it asks you for a new file, it doesn't go into a random folder. It takes you 5 minutes to find that path. Then we're going to create a study design to compare ignore letters group with memorized letter. I'm not sure I mentioned that in details, but if you select both ignore and memorize, when you create a design and you type on the group, it's going to create a new condition, ignore and memorize group together. And you're going to compare this to probe letters. You're going to recompute the spectrum, and you're going to plot scarp topography at 10 Hertz for both conditions. There we go. So I said, here, so I'm loading the study. Load study. Alright, so who wasn't able to load the study? Everybody was able to load the study. Here, Stain study, loading the study. And then I said create a new condition, probe versus, so go to the study design. So that's the menu to go to the study design right there. Again, the best way to do the exercise is to go to the slide and look what was done in the slides. And then create a new design. So here I already created it. I can add a design or modify my current design. So let's say I add a new design, and by default it's the same design as the previous one. If this is not present, ignore versus memorize. I can combine selected value, and then I have a new one I can select. So ignore versus memorize and probe. So it's a 1x2 design. I press OK, and then we said compute the spectrum. So now it's the third menu, pre-compute channel measures, spectrum. I don't change anything, I just click spectrum and OK. So it's computing spectrum, it's going to take a few seconds. And then I said plot the spectrum at 10 Hertz. So this was a bit more challenging because I didn't describe really quick how to select frequencies. Subject 12, subject 13. Done. Plot channel measures. So the scarp topography, so it means for the scarp topography I need to select all the channels. So select all the channels for the scarp topography. Parameter, so I don't want to plot each individual channel, I want to plot the topography. So I just said 10 Hertz. I can also put 8 to 12. So it's going to average between 8 to 12. So after I select all the channels, I click on parameters, select the topography at 10 Hertz, press OK, then press this button, reading each of the channels and plotting the topography. Done. Any question? No? If you have a bug, just raise your hand and somebody is going to help you. Yeah, we have one person over here that's... Is it a bug?
I think so.
Yeah, okay. Ramon is just in front of you. So let's move on to how do you do statistics. So now we're going to move to statistics. So we're done with this exercise. And again, on the last day, whichever exercise you were not able to do, you can go back to it and we'll try to help you. Before I go to statistics, I also wanted to mention we'll look at that tomorrow in more details. But everything you can do with channels, you can also do with ICA components. So once you've selected your design, you can also pre-compute component measures. So that's the menu for the component measure. You can see it's the same, except it doesn't have interpolation, because its interpolation doesn't have any meaning for ICA components, so you can't select interpolation. But you have ERP, you have power spectrum, you have ERSP, etc. It's actually the same function that does both ICA or channels. So everything we've done with channels, you can do with components, except plotting, grouping, well, you can group them as well. But then you can edit plot cluster. And now this is a little bit different interface. Now on the left, we have groups of components, and on the right we have individual components. So when we were dealing with channels, we had the grand average on the left and the single subjects on the right, so it's exactly the same for components. If you want to plot groups of components, it's the left, and individual components on the right. We have plot ERP, spectra, ERSP, ITC. We can plot the scalp topography of components, dipoles. So we're going to look into that tomorrow. This is just some example of what you can plot. So scalp topography of components. These are not individual components, these are average, so groups of components. So this is the average scalp topography. And if you select one individual, what we call cluster, and you select to plot all the components, you'll see the individual component in that cluster. So if it says IC4S01 means independent component 4, subject 1, IC11, subject 2, etc. So these were the ones which were grouped together. And we'll see how to group them tomorrow. You can also plot the dipoles. So these are the dipoles for the components of that cluster. You can see they're grouped together. As for the ERPs, you can plot the ERP for that cluster in the free conditions. Ignore, memorize, probe. And you can do also some statistics. So now we're going to talk a little bit about statistics. Oops. PowerPoint crashed again. It doesn't like when I switch resolution. Okay. So for both, so now we're back to channels, and then we want to use statistics. So there was a small parenthesis about you can do the same thing with components. We're going to talk more about it tomorrow during the clustering session. So you saw there's this big button, statistics. So you just click on it right there. And this is what pops up. And it tells you, okay, what kind of statistics do you want to use? And this is not the GLM yet. So here it's simplified in the sense that, okay, I want to compute independent components on my first independent variable. So that's condition, which is probe, memory, probe letter, ignore letter, and memorize letter. And then what kind of statistics do you want to use? Well, I want to use EEGLAB statistics, and then you can select different types of statistics. So we'll go into that in a while, but if you just select the default, which is like use parametric statistics, it's very fast, that's the advantage, so it's good to just have a look at your data. And then you want to exact p-value. So this is what you get. This is the p-value across time. And you can also plot the statistics. Did PowerPoint crash again? Oh, my laptop crashed. No. So you can also plot statistics below the ERP. Instead of just in a separate plot, you can also set a threshold and plot it below the ERP. Maybe I'll just do it like this for now to make sure it doesn't crash again. So that's the example where if you set a threshold, so now you collect this, you go back to statistics, you set your statistical threshold, so now it allows you to plot statistics on the bottom. Okay, so now it's black bars wherever it's statistically significant. And then you can use different methods for correcting for multiple comparisons. So Cyril already talked about these methods. You can also plot scarp topographies, by the way, and statistics for scarp topographies. So this is the statistics you can use. So for EEGLAB statistics, you can use parametric statistics, you can use permutation statistics, and you can use bootstrap statistics. Difference between permutation and bootstrap, like numerically, gives you almost the same result. In theory, it's better to use bootstrap because permutation just swap your subjects under the null hypothesis. So it's equivalent as the issue is that it's like when you have a bucket and then you take individual subjects, you put them back when you do permutation. So from a statistical perspective, if you want each of your draw to be independent, it's better to use bootstrap. So there's theoretical reasons to prefer bootstrap. In practice, permutation and bootstrap give almost indistinguishable results. And then correct for multiple comparisons. So you have the ohms, the Bonferroni correction. You have the ohms and the FDR correction. I don't know if Cyril talked about the FDR correction. The false discovery rate. It's a very popular method. Or you can use other types of statistics. You can use the field trip statistics where you can use parametric statistics or Monte Carlo permutation. So these two are equivalent. So if you use parametric here and parametric there, it should give you the same results. If you use permutation here and permutation there, it should also give you the same result. Here you don't have the bootstrap for the second option. But here you have more correction for multiple comparison. So you have Bonferroni, you have ohms, you have FDR, but you also have the max correction that Cyril talked about, and then you also have the cluster correction. And then you don't have the very new one that Cyril talked about, which is like the improved cluster correction. But this is available this afternoon if you come in the beta release of the new EEGLAB version that allows to do many more things. So basically, right now we're using the version that's available online. That's the default version. This afternoon, if you come to the parallel session that's on general linear model, we'll use the new version. And the new version can do exactly the same as the old version. They're actually backward compatible, so if you have scripts in the old version, they'll work in the new version. But it has a new way of defining design, and you can see your design matrices, and then you can compute more things, and then you can use more advanced statistics to correct for multiple comparison. So that's it. These are the statistics. So you select your statistics and you select the type of correction. If you select parametric statistics, the cluster won't show up because the cluster only works for permutation. So remember that when in the exercise we're going to do right now, there's actually one where you want to select the cluster correction. So remember that if you have parametric, it's not going to work, so it won't even appear. It won't even be there. And then you select all the defaults. There was one slide here. Yeah, parenthesis about single trials. So you can use also your single trials, which means that you can use single trials in your statistics. And that's, for instance, whenever I want to look at one subject, because you can do many more things in study, like in terms of selection of conditions, etc. I usually create a study with a single subject, and I use single trial to do statistics. So it's instead of having multiple subjects and do statistics across the subjects, it's just using one subject and does statistics across trials. You can do both simultaneously as well. Use trials and subjects and try to do statistics. But there's theoretical issues for which you might not want to do that. It's not wrong to do that. It's just better to do that in the GLM model because it's more rigorous. So if you select single trials and want to do statistics using single trials, just do it if you have a single subject. Don't do it if you have multiple subjects. A major difference also between the versions we're using now and the version we used this afternoon is that in the version we're using now, every time you have a design, it needs to recompute your averages, your spectrum, your ERSP, etc. In the new versions, it just computes it once, and it stores all the single estimates on disk. So all the single trial estimates are stored on disk. So the new version requires much more disk space, but at the same time, you only have to do it once. You do it once for all the design. Here, every time you have a new design, you have to recompute your measures. So let's just do this exercise real quick about experiencing with study statistics. So we're going to take the same data you were just using and the spectrum you've computed, and first use this parametric statistics with EEGLAB methods and use FDR correction, for instance, to plot without correction and after correction. And then also try to use the cluster method. So that's the second one in field trip to correct for multiple comparison. I just want to advise you, this one is very slow. So, just don't be like, oh, I've been waiting 3 minutes. Well, that's normal. We actually have a version that's 1,000 times faster, but we haven't released it yet. So just be aware when you click, just click that button. It used to take 1 second. Well, now it's going to take 3 minutes to correct for multiple comparison.